Hi there and welcome back to 355 Code. Today we'll be creating a bowling game together using HTML, CSS, and JavaScript. So let's dive right in. What I have set up here already is a basic HTML document where I've added one pin and one ball for which I've already created all the CSS over here. And let me just give you a look at that. So you can see here already I built a pin using CSS, primarily using the before and after, as well as coloring, gradients, etc., just to kind of build out this pin. If you want, you could also use an image of a pin or something that you create by yourself. That's not going to be the focus of our tutorial, and the same goes here for the ball. One interesting thing to point out about the ball is that I've added cursor grab and cursor grabbing so that we kind of have this effect. If you see that kind of hand that's over the ball, when I hover and when I click down, it kind of makes this grabbing motion because we're going to be dragging this ball around in order to throw it at the pins. And right here in our JavaScript area, I've kind of just set up our to-do list. So first of all, we're going to start with arranging the pins in triangle like they are in a regular bowling game. We're going to add a lane, which is a visual element mostly. And then we're going to really work on the functionality, which is dragging the ball, throwing the ball, something to indicate kind of the force and direction that the ball will be going in. And at the end, of course, we're going to want to knock down the pins and maybe display some kind of message about how many pins were knocked down, or some kind of congratulations, etc. So let's dive right in. First of all, we're going to want to arrange the pins. So in order to do that, what I'm going to do is I'm going to separate these pins into rows. So I'm going to add a div over here. And I'm going to call this div, I'm going to give it a class of row, and I'm going to kind of just arrange the pins within a row. So let's start by creating one row with just 5 pins. So I'm just cutting and pasting my pin here 5 times, and let's just format that. Great, so now let's see what we have here. So as you can see, the pins are kind of just stacked one in front of the other, which is not really what I want. I want them to be side by side. So let's start adding some CSS here to style those rows. So we're going to want this to be display flex, and the flex direction is going to be row. So let's run that and see what we have, and great. So we already have these 5 pins kind of just lined up side by side. And what I'm going to do is I'm just going to justify content to center. And this should really move our pins kind of to the center of the display so that they're across from this ball, which I already centered using CSS. Great, so now let's see what happens if we add another row of pins. So I'm just going to copy this row over and take one pin off. And let's see what that looks like. Okay, so they're kind of stacked. To me, they're a little bit too far apart from each other. Imagine if we add all the rows in, then we'll be kind of losing the kind of 3D effect a little bit. So what I'm going to do is I'm just going to try knocking some of the height off of these rows. So let's put the height at 30 pixels. And now they're kind of in front of each other. Let's see what it looks like with 20 pixels. And they're even more in front of each other. So you can really play with it by yourself and see what looks visually best to you, but to me this looks okay. And I'm gonna add in here 3 more divs, and one is gonna have 3 pins and one is gonna have 2 pins, and one is just going to have one pin for the front. And let's style this. Oops. Okay, let's run that. Excellent. Okay, great. So we have all our divs set up, and that is our pins. And the next thing that I said we're going to want to do, let's take a look at our to-do list, is add a lane. Okay, so in order to add the lane, let's just add something right over, a div right here between the ball and the pins, and let's give this a class of lane. And let's, for now, I'm going to set this up right here between the pins and the balls in my CSS. I like to organize my CSS kind of just by some kind of logic. So here you can see that it's really from top to bottom and from, parent to child. That's kind of how I've organized it over here. You might be following some other kind of convention. I know some people do it in alphabetical order, however you deem best. So for the lane, I'm going to start off by just giving it a height and a width and a background color. Let's just choose, let's say, this blanched almond because it looks a little bit like wood. And I run my code, and I do not see this lane. Let's see. Here I wrote border color instead of background color. Excellent. And here's the lane. Okay, so what we want to do is we kind of want to center that. So let's give it margin auto. Let's see if that helps. Excellent. So now it's kind of centered right here. And we really want this to be a lot taller, probably something like 400 pixels, so that it really comes up all the way behind this ball. Let's try a little shorter, maybe 300. Another thing we're going to want to do is we're going to want to give this a 3D look, right? Because imagine we're throwing this ball down the lane, so the pins are kind of farther away and the ball is closer. So we want to kind of give this a slightly triangular shape so that it has some perspective. And the way we're going to do that is by really turning it on using transform. So let's try that right now. So what we're going to do here is we're going to add a transform, and we're going to be rotating it on the x-axis, okay, because the x-axis is from left to right, and we kind of want it to rotate around this, if you can imagine like a stick here, that it's rotating around, and that way it'll rotate either closer to us or farther from us. So let's try and give it, I don't know, even 10, let's give it something a little more, maybe 40 degrees rotation on X. Okay, so you can see that it just kind of made it a little shorter. And in order to fix that, what we need to do is we need to give this transform a little perspective, which basically is kind of a representation of how far we are from this object that's being rotated. So let's just even give it like a 10 pixel perspective. And that didn't change much. I made it a little longer. Let's try giving it something more, like 100 pixels perspective. Okay, and this didn't change much. Let's try changing our rotation a little bit. Let's say 10 degrees. And we're still not getting much of a change. So what I'm going to try and do is add a little more width. So let's say 100 pixels. Okay. And here we go. Our usual typo. It's perspective, not perspective. And let's do that. And now you can see that our perspective has been applied and it gives us this kind of 3D shape, which is kind of like a trapezoid. And I'm going to add a little more width to this lane because we should kind of have pretty much all the pins sitting on the lane. So let's make it even a little wider, maybe like 300 pixels wide and maybe 400 pixels long. And I'm going to need to move it up a little bit so that the pins are sitting on top of it. So let's do that with translate Y, and let's just translate it up, let's say minus 100 pixels. And that was pretty good. Let's try minus 200 pixels. Okay, and you can see that it's kind of getting smaller and smaller because it's moving. You can imagine it as moving away from us. So we might want to fix that up here in terms of our, the height. Maybe make it, let's say, 500 pixels. Okay, that's pretty good. Let's see, we want to change the Z index so that it's really sitting behind our pins. Okay, that didn't really help us very much. So in order to fix that, let's check what position our pins have. So these have a position of a relative. So let me try giving a position of relative to the lane as well. Okay, and now you can see that our lane is behind the pins. And I'm going to try here, instead of using this translate, I'm going to try using top and bottom. So let's say top, let's say, I don't know, 70 pixels. Okay, so that moved us down. So let's do minus. Okay, that moved us up. Let's try 150 pixels. Excellent. Okay, so now we really have our setup like we want it. We have pins and we have a ball and they're sitting on a lane. And now we can really start jumping into functionality. So check, and now drag ball. Okay, so in order to drag the ball, we're going to want to add some event listeners for our ball. And because we want this game to work both on mobile and on desktop, which should be pretty much standard practice for any game, we're going to be using the pointer events. Okay, so not mouse events, but pointer events. And pointer really includes anything that you are using to interact with your display. It can be your finger, it can be a mouse, it can be a stylus, etc. So it's really a more dynamic and inclusive event listener. So let's start by, I'm going to add an ID to our ball, just so it's a little easier to select. And let's say const ball equals to document dot get element by ID ball. Okay, and let's add an event listener. So ball dot add event listener, and we're going to be listening for the pointer down event, and let's call this handle grab. Okay, and now here we're going to really need to write a function before handle grab. And let's think what we want to happen when we grab the ball. So when we grab the ball, we are going to want to basically move the ball to wherever the mouse is when the mouse is down, okay? So in order to do that, we are going to need to keep track of where the mouse is. So for this, let's just add okay, so actually before handling this, I'm going to actually deal with the ball moving. So let's make another function. We'll call it ball move. Let's call it ball drag, just to be a little more specific. Okay, because we're really going to be dragging our ball. Okay, and this ball drag is going to be fired whenever we move our mouse. So this is really document.add event listener pointer move. And here we're going to do ball drag. Let's call it drag ball, or handle drag ball. Okay, and I'm going to change my function over here just so we have some consistency. Excellent. And now what do we want to happen when we drag the ball? So basically we want to pick up on the X and Y location of our pointer. And in order to do that, we are going to declare two variables. So let's say let mouse X equal to event. So the event is the event that fires the event listener, and dot page X. Okay, and let mouse Y equal event dot page Y. Okay, and what I'm going to do here is I'm going to console dot log mouse X mouse Y just to make sure that everything is working and to show you as well. So let's first save our code. That's always a good idea. And we're going to run it and open the console here. And you can see that whenever I move my mouse, we are logging the position, the X and Y position of the mouse. Okay? And now basically what we want to do is we want this ball to go to that position of where the mouse is. So I'm going to erase this console because we got the point. And basically what we're going to want to do is we're going to want to set the top and left positions of the ball. And before we do that, we are going to have to so let's do that right here. Okay, so let's say ball dot style dot top equals mouse Y plus pixels. Okay, and let's say ball dot style dot left equals mouse X plus pixel. And this, we have to add this pixel here at the end because this really is a string and it has to have pixels in it. And let's try running our code. And you can see that now whenever I move the mouse, the ball moves with it. But there's a slight offset because of the size of the ball. So you can see that my mouse is kind of really on the upper left corner of the ball. But we want it to be in the center. So what we're going to do is kind of give it an offset. So let's double check what the size of the ball is. And we see it's 60 pixels by 60 pixels. So what I'm going to do here is I am going to, let's try adding 30. I'm actually not sure if we need to add or subtract here, but I'm just going to try it, and worst case we'll turn it around. Okay, so the other way. We need to subtract 30. Let's run the code, and now you can see that the ball is kind of, the cursor is in the center of the ball whenever we move it. So great, so that's a great start. But we actually don't want the ball to move every time we move the mouse. We only want it to move it when we're actually grabbing the ball. In order to do that, we're going to turn now to our handle grab function, which will really tell us if we are grabbing the ball or not. So let's make like a global variable, and we'll call it, use that here, ball drag. Okay, and we're going to start it off as false. Okay, and then what we're going to do is that when we fire this pointer down event, we are going to change this ball drag to true. Okay, and then here we're going to say if not ball drag. Sorry, so let's say, if not ball drag. Okay, so that means that if ball drag is false, return. And this will act as kind of a safety clause. That means that if ball drag is going to be false, then this if statement will be true, and then we're going to exit this function. So we're not even going to execute this, the moving of the ball. And only after we grab it down, then it'll be true. So let's save and run our code. And we can see that now when I move the mouse, the ball is not moving at all. But if I click down on the ball and then I move the mouse, then our ball is moving. Okay? But when I let go, it's still moving. So that's a problem. So now we really need to add another event listener. And let's say ball dot add event listener, and this is going to be for pointer up, and this is going to be handle, let's call it drop ball, or let's say handle throw ball. Okay, because what we're going to do now that we're finishing up with drag ball is we're going to start focusing on how to throw the ball. And the way the ball will be thrown is that you grab the ball and you pull it back, as if you're pulling your arm back to build momentum. And then as soon as it's released, it flies forwards into the pins. Okay, so that's why I'm calling this function handle throw ball. And I'm going to write out the function right over here. So handle throw ball. And the first thing that we're going to do here is we're going to say ball drag equals false. Okay, so now you can see that if I drag this ball, okay, and then I let it go, then it doesn't move anymore. This is not 100% necessary, because really what we're going to do is let this ball fly forward kind of whenever it's let go. But for now I'm going to leave it in the code, and if we don't need it at the end, then we'll take it out. Great, so now what do we need to do? So what we want to happen is that when we let go of this ball, it will move. Okay, so first of all, I'm going to just get it to move without any kind of guidance or specifications, just so we see how we can make the ball move in a certain direction. So basically what we want to do is we want to change the top and left of the ball again. So basically, let's just say ball dot style dot top equals, let's just say we need to tap into the current top of the ball. So let's say it's ball dot style dot top, and let's say -10 plus pixels, and we're going to want to run this at an interval so that it keeps on executing to kind of show how the ball will move. So let's set an interval, and for now let's have it run, let's say every 100 milliseconds, so 1/10 of a second. And I'm going to put that right over there, and while I'm at it, I'm just going to format our document over here. Great, so let's see what happens now. So I drag the ball and I let go and nothing happened. Drag the ball and nothing happened. So we know that this code is executing because ball drag is turning into false, but something is not working here in the set interval. So I'm going to do here console.log ball.style.top. Okay, and run the code and drag, let go, and you can see here that it's 452 dot something pixels. Okay, so this is a string, but 10 here is a number. So we need to convert this into an integer, into a number, and we're going to do that by using something called parseInt. And this will turn this into a number. And now if we run our code again, and I drag and let go, then you can see that our ball begins to fly forward into the pins. Okay, so we're nowhere near done, because you can see that the ball just flies forward with no relationship to how much force we were throwing it with or the direction. But that's just kind of to give you a general idea of how this is going to work. So let's start thinking about how we can change the direction of the ball based on where we let the ball go. Okay, so to do that, we're going to need to record the starting point of the ball, and we're going to need to record the ending point of the ball in terms of XY coordinates. So let's start declaring some variables up here. So let ball start X. Okay, and I'm going to start these all off at 0. And let ball start Y. Also going to start off at 0. And ball end X. And ball end Y. As 0. Okay, and basically we're going to use these to kind of keep track in global variables of where the ball started out and where the ball ended. In order to figure out where the ball started, basically we're going to change the ball start X and ball start Y when we have our handle grab. And so we're going to want to keep track here of ball start X, and that's going to be equal to ball dot style dot left. Okay, and I'm going to already put the parseInt here, just so that we really save the ball start X as a number. And we're going to copy this and just do the same thing really for ball start Y. Whoops. copy, not cut. And this is going to be top. Excellent. And now what we want to do is we want to do the same thing for when we release the ball. So right over here, when we handle throw ball, let's say right ball and x is going to be equal to the same thing as over here, and ball and y is going to be equal to this over here. Great. And now what we want to do is we want to really, figure out the difference between ball start x and ball start y. And that will help us figure out, our angle. Okay, so in order to figure out the angle, we're going to need to start applying some trigonometry. So either you can brush up a bit on your trigonometry, or you can just listen to what I'm saying, and hopefully you'll be able to follow along. So in order to calculate our angles, what we're going to need to do is we're going to need to find the distance from the original position in both on the y-axis and on the x-axis, and then calculate a tangent from which we will calculate the angle. So let's take a look at the basic trigonometry behind how we're going to move the ball. So right over here, I just did a basic search for trigonometry on Google, and I'm taking a look at this diagram here. And if you can imagine that our ball starting point is right here on the bottom of this, on the bottom left corner of this triangle, we're going to want to calculate the distance between this point and this point. Okay, this is the final point that our ball ends up on when we are letting go of it and throwing it. And this is the angle that we're trying to figure out right here. Okay, so in order to figure out this angle, we're going to be using tangents, and that basically means we need to find the adjacent and the opposite. Okay, so the adjacent is going to be our y-axis, because you can imagine kind of turning this triangle 90 degrees. So this ball will be up here, and then this, because we're dragging it down, not to the right. So the adjacent is going to be our y-axis, and the opposite is going to be our x-axis. Okay, so let's really start doing that in our code. So let's say let adjacent equal, so first of all, let's calculate the distances. Okay, so we're going to say dist y is equal to ball end y minus ball and ball start y. Okay, and dist, this is the adjacent. Okay, that distance is the adjacent, and this is the opposite. Okay, this is going to be ball end x, ball end y. Because basically, if we take a look at our diagram again, right, so this value is going to be the ball end y, okay, and this value is going to be the ball end x. So the distance between here and here, that's the opposite, and the distance between here and here is our adjacent. Okay, and then we basically need to figure out, let's say the tangent is equal to adjacent divided by opposite. Opposite divided by adjacent. Okay, And then we're gonna use a JavaScript method, which is used for finding an angle. And let's find our angle. And I'm just gonna write here rad because this is really our angle in radians, not what we're familiar with usually, which is degrees. And the way we're gonna find that is by using math.atan. Okay, so this basically is a reverse tangent. Okay, so it finds the angle using a tangent. And I'm going to put here our tan, which is our tangent, and that should find our angle. Okay, and then when we are releasing our ball, okay, so here we have for ball style top. Let's copy the same thing over here for left and right. Sorry, this is also left. And basically what we're going to want to do here is we are going to want to use this angle rad that we calculated to change the kind of the amount that we're moving top and left. So in order to do that, we're going to need to convert our angle back into using cosine and sine. And the reason I'm doing it this way is because these will basically give us a number between 0 and 1 that we can multiply any other number by, and then we'll get a relative, the relative movement that we need on that axis. Okay, so the way to do that is just using math.cosine, and here we're going to pass in our angle rad, and then we are going to multiply it by this 10. Okay, and the same thing we're going to do here. This is math.sine and angle rad, and we're going to multiply it. Okay, so now after we did all those calculations, let's see what happens in our code. So when we run our program, so I'm going to take the ball and I'm going to drag it, let's say, at this angle, and then I'm going to release, and math is not defined because I have a capital A here. And let's try that again. So I'm going to drag it and release, and nothing happened. Okay, so now it's time to start debugging. So let's console.log all of the things that we calculated over here. So let's say opposite and angle rad, just to make sure that we're getting those values like we should be. Okay, so we got here null and null. So we're having a problem with our adjacent and ball end y minus ball start y. Let's see, ball end y. Okay, so let's console. Over here, let's console .log ball end y and ball. Okay, so here I already see one problem, is that we have here ball end x minus ball, this should be start x. Okay, so and then we're going to console this here, ball end y and ball start y. Let's see what's going on over here. Okay, so ball start y is null. And let's see why that's happening. So this should be setting when we grab. So let's see if I console it in here, what values we're going to get. And debugging is really part of coding. So if this doesn't happen to you while you're coding, then you know, something interesting is happening to you. Okay, so let's just console here, ball dot style dot top. Let's try that. Okay, and we're getting here that ball dot style dot top is blank. Okay, there's nothing. Nothing coming back. So in order to fix this, what we're going to do is, instead of changing the okay, so there's two things we could do. I could move the ball start X and ball start Y into this handle drag ball function, but I don't want to do that because I want to try and keep things clean. So what I'm going to do here is I'm going to add here event, and I'm going to set these, instead of using the ball's left and top values, I'm going to use the page X and page Y values, just like we are doing down here. And that should give us an accurate representation of where the ball is. It might be slightly off if somebody grabs the ball, let's say, on the upper right side, but let's try it out and we'll see how that works for us. So drag the ball, let go, and now you can see that the ball is moving pretty much in the opposite direction that I dragged it from. Let's try it from here. Yep. And let's say that, and it's going pretty straight. Okay, so you see it has a slight tilt. But it is pretty accurate. Okay, it's not 100%, but it's maybe kind of 98% there. But it's still a little hard to know which direction our ball is going to go in when we release it, and it would help if we had some kind of guide which kind of shows us the general direction the ball is going to be flying in. So let's try working on that now. So in order to do that, let's add a div. It's going to be kind of right under our ball. And we're going to call this the ball guide. Okay, and I'm also going to give it an ID of guide, just so that we can select it more easily in our code. And let's add some CSS to this guide. So I'm going to be adding it here right after the ball. So let's give it a background color of red, just so it's like super visible. Let's say width 10 pixels, height 10 pixels. Let's see if we already see it up here. And now we can see it. It's right here on the bottom left corner. And let's try and, I want to kind of move it so it's positioned pretty much right under the ball. So let's change position to absolute. And let me try moving it up. So let's say top I don't know, 400 pixels. Okay, so that's almost parallel. And I want to center this, and it's kind of hard to center things that are absolute. So what I'm going to do is I'm going to give it also a left. And this is going to be, for this left, I'm going to use the calc function, which basically lets me run a calculation and then based on that determine the left attribute. So we're going to do 50%, which you can imagine moving it towards the middle, and then I'm just going to subtract from that 5 pixels, which is half of the width of this ball, and that should really put it right in the middle of our document. And you can see here that it's kind of peeking out right behind our ball over there. So let's do top 410. And now it's not visible at all. So now this guide is kind of hiding behind our ball, and you can see it when I move the ball. There it is, ta-da. And now what we want to do is we want that guide to basically stretch when we move the ball. So let's start with the easy part, which is stretching it on the y-axis. So let's say that we will let's make a new function, and let's call this adjust guide. Okay, and then when this function runs, we're going to pass it, let's say, the adjacent. Okay, and then we're going to set the height of this guide. So for that, we're going to need to select it up here. Okay, and then let's just set guide dot style dot height, dot height, and that will be equal to adjacent plus pixels. Okay, and we're going to want to call this when we throw ball. So no, actually we're going to want to call this when we're dragging the ball. Okay, so because we're going to want to do that, that basically means that we're going to need to move around some of our calculations. So let's move our calculation of ball end x and ball end y up over here. For now, I'm going to put it over here, right under our the rest of our code. And here we're going to need to call the adjust guide function, because we want this basically to happen every time we move the ball, not only when we let it go. And in here we'll just call it with for now I'm going to just declare a JSON. I'm going to say let equal ball y minus ball start ball end y minus start ball y, and here let's try that. Okay, so I grab the ball, I move it, and now you can see that our guide is getting longer and shorter based on when we move the ball. Great, but we also wanted to change the direction, okay, to kind of give an indicator of what direction it's going to be moving in. And to do that, we can basically add a rotation. And I'm seeing here that a lot of our calculations are going to need to be done kind of separately. So let's add another function, and let's call it angle calc. Okay, and here we're going to do all of the calculations that we were doing over here. So let's say these three calculations I'm going to move to this function. And let's add the declarations here that I forgot before. Okay. And for now, we're going to return so let's say calc, and here we'll have adjacent and angle rad. Okay, and that's what we're going to return from this function. And then over here, basically, let's say we're going to use a deconstructor. So let's say let angle rad equal return angle calc. Okay, and now let's just see if our code is still working, and it is. Okay, so that kind of separation into a function worked, and now we can use this angle calc function elsewhere in our code. For example, over here. So here, this will be equal to angle calc. Okay, and then we can adjust the guide. And another thing we're going to want to pass into adjust guide. So actually, let's simplify things, because ideally we don't want to be passing arguments into our function. So let's move that down over here. Okay, and we can actually deconstruct angle rad as well from angle calc, and we can just do that all over here inside of our function. I'm going to reformat the document, get rid of this parameter. Excellent. So let's just double check, make sure our code is still working, and beautiful. So now we really need to work on that whole angle change, and in order to do that, we are going to want to rotate this guide. So let's tap into guide.style.transform. And that will be equal to, I'm going to be using a template literal here. And let's focus first on just rotating it. So let's say rotate. And the amount that we're going to rotate it by, this could also be in radians, which is great for us. And we're going to do it, let's say angle rad. And just here we need to write rad instead of degrees. Okay, so let's try running our code, and okay, so we're getting an opposite rotation. So basically, to fix that, I think we could just put here a minus before angle rad, and let's try that again, and great. So we're getting a rotation which kind of indicates the general direction that the ball will be flying in. Okay. And another thing that we might want to do is just to kind of give this a little perspective as well, just that we have a feeling of like a growing force as we drag back. Okay, so in order to do that, we're going to need to add some perspective here as well. So let's add perspective. And let's say 100 pixels. And when we rotate, we're going to want to rotate it also around the x-axis specifically. And the rotation around the x-axis will be determined by our adjacent, because that is what's deciding the height and the force. So basically, let's use our adjacent here, and this will be in degrees. Okay, so let's just see what this does for us. And this is always going to be a little bit of tweaking the numbers, playing around. And okay, so we see it flipping around a lot here. Seems to be going a little crazy. So let's try, I mean, this adjacent might be pretty big. So see if it's getting to more than 180 degrees, it flips around. So let's try dividing that, let's say by 5, just to make it a smaller number. And you can see here that it's not flipping nearly as much, unless we go really, really far back. But we are getting this nice kind of expansion that makes it seem, you know, gives us this imaginary force that we can imagine here for the ball. And then that's the last thing we're really going to want to do, which is actually calculate that force. And that force is going to be determined by our tangent. Okay, because that, sorry, it's not going to be determined by our tangent, but it's going to be determined, if we take a look back here at the trigonometry, it's going to be determined by this angle that sits right across here from the right angle. So in order to calculate this, we need to use Pythagoras's, there's a lot of math here. I apologize for those of you who are not so math prone, but you kind of need math to figure out all these physics things. And yeah, so we're going to use his theorem to calculate that the length over here, okay, of what's sitting across from the 90-degree angle. So we're going to do that in our angle calc function. I think that makes the most sense. And so let's say that so actually what we're going to do, I'm going to declare a global variable, and I'm going to call it force, and I'm going to start it off at 0. And here I'm going to say that the force is going to be equal to, so basically we want the square root of this squared and this squared, of the adjacent and the opposite squared. Okay, so let's start with math dot square root. Okay, and we want the square root of math dot power of opposite 2 and math dot power of the adjacent 2. Okay, and so this is how we're going to calculate our force. And then basically what we want to do is when we are releasing the ball, okay, we are going to want to speed up the ball's movement based on the force. Okay, so it's not going to determine anything here, but it's really going to determine how fast we run this interval. So now let's just put our force into this set interval and basically speed up the ball just using the force. So in order to do that, what we want is a relationship where as the force gets bigger, the ball will move faster, and basically our interval will need to be shorter. So that means we're going to want to divide our interval by force. But we're also going to want to make this starting point a little bigger. Let's try 1,000, because otherwise it'll be really, really fast every time. So let's try running our code and seeing how this works. So, okay, that was pretty fast, and I didn't even stretch it back very far. So let's try doubling that. And let's see now. Okay. So that wasn't too bad, and let's see if I only stretch it a very little bit. Whoops, okay, that was the wrong direction. Pull it back a little bit. Okay, I'm detecting that we have some kind of bug here, because as you can see, if I move the ball to over here, it's already throwing it way off to the side. So we're going to need to take a look at that soon. But let's say I pull it back really far, the ball runs really fast, and if I pull it back just a little, then it goes rather slowly. So the force is working. And now let's just go through our code for a second and see if there's anything that might be throwing off our angles. Because if I pull it just a little bit over here, you can see it's going completely in the wrong direction. So we're back, and I decided to spare you the debugging this time, but this is what I've discovered. So basically, we've been declaring ball end and X and Y based on the ball's left and top specifications. But as you can see here, we've actually defined those to be as 30 pixels basically to the left and top of where the mouse is located. So we're basing part of our equation on where the mouse is located and part based on this skewed position of the ball. So if we change these two to event.page X and event.page Y, I think that that should give us a little more accuracy. And let's check that out. And there we go. So now you can see that the ball is really following the instructions that we gave, both on direction and on force. And you can tweak these depending on your own preferences. If you want the ball to go faster, slower, or if you want the angle to change more drastically based on how you move the ball. But we're just introducing the basic concepts here. So the next thing that we're going to want to do is to make our pins fall down when the ball reaches them. So in order to do that, we're going to be adding some CSS animations. And I'm going to add them here right after ball guide. So to add a CSS animation, you have to use at keyframes. And let's call this pins fall. Let's just call it fall. Okay, to keep things simple. And then basically what we're going to want to do is 2 that specifies the end result of the pins. And what I'm going to do is I'm just going to make all the pins fall down when the ball reaches that area to simulate getting a strike, for example. So let's say transform, rotate 90 degrees. Okay, and then what we're going to do is we're going to add another class, and let's call it fall as well. And here we're going to add the animation name of fall, and let's say duration 0.5 seconds, and let's try and see what this does for us. So basically, as soon as we throw the ball, what we're going to do is have these pins fall, but let's do it at a timeout, right? Because we don't want the pins to fall, as soon as we let the ball go, we want the pins to fall kind of when they reach that area. So let's say a timeout with 1,000. And what we're going to do is we're going to want to tap into all of the pins that we have in our DOM, right? So basically, to do that, what we're going to do is we're going to select all the pins. So let's say const pins equals document dot select query selector all. That's what I was looking for, and we're going to select everything with the class of pin. Okay, and basically what we can do now is kind of loop through all these pins and apply the style to them. So we set a timeout, and then let's say pins. So we can't really use the for each here, but what we can do is create a regular for loop, and let's say for let I equal 0, and let's say I equals 0, and while I is smaller than pins dot length I plus plus, and then basically what we're going to do is for pin I pins I dot style dot dot class list dot add, and we're going to be adding that class of fall. Okay, so let's see if this works. And there you go. So you saw that as the ball reached the pins, they all just kind of fell to the right. But they got right back up again, which is not what we want. So here, what we want to do is add here animation fill mode. And that's going to be forwards. And basically that means that the animation will only happen once. So if I let the ball go, boom, the pins all fell down to the right. And you can play around with this and adjust it so that, some of the pins fall left, some of the pins fall right, so some of the pins move around. And you could do that by adding more transformations to this fall animation. You can add several different animations and attach them to different pins. But I'm just kind of explaining the basic concept to you. One thing you might want to change, though, 1 second, run our code again. One thing we might want to change is that, if our ball goes really slowly or really fast, it might not be timed up because we set it to a constant of 1,000 here, of 1 second. And what you can do is you can really play around with it and time it so that it's also relative to the force and the speed that the ball will be moving at, and that way let your pins kind of fall at it when the ball reaches them. Okay. Another thing I'm going to do is I'm going to add an animation to the ball itself, so that it kind of looks like a bit like it's rolling around. So in order to do that, let's add another animation. And this we're going to do transform, rotate, let's say 10 degrees. Okay, and let's add this as roll, and I'm going to copy all of this. but I'm going to change this to roll, and I'm actually going to take away this animation fill forwards. And let's say iteration count infinite. Okay, so I want this to continue rolling infinitely. I don't want it to stop at any point. And now what we're going to do is basically when we throw the ball, we can add this ball.classlist.add, and we're going to add the roll to it. Okay, and let's see how that looks. So I don't know if you managed to see it, but there was a slight roll. Let's try and change it to 30 degrees. And I'm going to make it roll a little faster, so maybe every 0.2 seconds. Okay, so that you could kind of see that it was starting to roll, but this iteration infinite kind of took it back to the beginning of the animation. So what I'm going to try and do is I'm going to try and add this roll into our interval. And that will actually be cool because it'll actually roll at the same pace that it's going forward, which actually makes a lot of sense. And let's try that now. Okay, so let's try adding the animation fill mode back. And let's see that now. Okay, so I think that our issue is that we can only add a class once. Once we add this class, then we're done. Our animation is done. So what I'm actually going to do is I'm going to move this to the bottom. Whoops. And I'm actually going to remove the class each time we reach this interval. So we'll be removing the class and adding the class back at the end. And now let's see what that does for us. Okay, it still doesn't seem to really be going, so let's try removing this animation fill mode. Let's try this even shorter. I'm going to change the approach. I'm going to make the rotation much bigger. So let's say 180 degrees. And I'm going to make it take longer. And I'm actually going to get rid of this remove roll. And let's see how that looks. So, okay, that looks pretty good. We're getting an almost full roll over there. And if I want, I can even make this, let's say, 360. And make it take a little longer, a few seconds. And yeah, that looks pretty convincing. If we want to add another small touch, what we can do is we can also kind of scale here. So let's say scale down to like, I don't know, 0.7. And that way that kind of the ball will also get kind of a little smaller as it rolls forward. So you can kind of see it going off into the distance as it hits those pins. Okay, good. So let's check out. Okay, so we arranged the pins, we added a lane, we added drag ball, throw ball, force and direction indicator, and we knocked down the pins. So the last thing we have to do is to add kind of like a strike message. So I'm going to add that on top here, above the pin wrapper, and let's just add a div. And I'm going to write here strike. And let's see how that looks. Okay, so obviously it's not styled at all. So let's add a class, and let's call this message. And now I'm going to add that in our CSS file. So I'm going to add that here right over the pins wrapper, and that's going to be message. And let's say font size 2em, maybe even 3. Okay, that's pretty good. Let's give it a position of absolute. And let's say left calc 50%. Okay, and let's say z index 1. Okay, and I'm going to give it a width just so that we can center it better. Let's say 100 pixels. Let's see if that's wide enough. Great. And then this is going to be minus 50 pixels. And there, that's in the center. And let's see how that looks. Okay. Let's say top 300 pixels. And then that strike goes out there right in the middle. And we could change the font if we want to. So let's say font family. Let's go with this one. So it looks a little more modern. And I'm going to just take off margins and padding. Okay. And looks pretty good. Still seems a little off center to me, but I'm not going to go too deep down into it to figure it out because it's not a key part of our game. What I am going to do is add a hidden class to it. So let's say hidden, and then I'm going to add a class here at the end that's called hidden as well, and that'll just be display none. And then you see it disappears, and what we're going to do is we're going to remove that class right over here. Okay, when our pins fall down. So that's going to be, I'm going to give it an ID of message as well, just a little easier to select. And then right over here, I'm going to add it const message equals document dot get element by ID message, and then over here I will say message dot class list dot remove hidden. And then basically if we run our game and we throw our ball, boom, we have a little strike message that appears here, and you can work on the styling of everything, and you can make everything fit to your specifications. What's important for me is that from this tutorial you understand, basic concepts such as how to arrange things using Flex, how to create a drag effect using JavaScript, how to calculate direction and force using a little trigonometry and some JavaScript methods. The thought that goes into how to create the guide, how to make a message appear, how to make pins fall, etc. And you can really work with those concepts and create your own game and even take it up a level. If you like this video, don't forget to like and subscribe, and feel free to comment with your own projects or with any questions that you might have. And see you next time.